This video is going to talk about isoquants, how we graph them and what they are. Isoquant is a contour line or a level curve of a production function. So we have a general production function here, F is a function of capital and labor. And we're going to use this two-input model that is very nice. It sort of parallels what we did for consumers in a two-good world. So we'll assume we have two inputs, and for specificity, we'll call them capital and labor. And actually, firms have dozens and dozens of different inputs. In fact, many different types of capital. Capital is like a produced factor of production, so any kind of tools. And think of all the different kinds of tools that they have in a Home Depot or a Lowe's, and that's just if you're doing contracting work. So there's lots and lots of different types of capital out there. We're going to condense it down into just two factors of production, one that we'll call labor, one that we'll call capital. And in this world, we'll have a production function where the production is a function of the amounts of labor and capital that the firm is going to use. So what we do for this is, because it's a level curve, you pick some level of production, some say output target for a firm, and let's just say that that's 20. And then what you do is you would go to the firm or go to the firm's engineers or production managers and say, what would be, if you have to produce 20 units of output, how much capital and how much labor would you need to have? And then I give you one answer here of like maybe 5 units of capital and 10 units of labor would work for that. And one way to think of that is that's one recipe you could use to produce 20 units of output. But maybe there are other recipes. Maybe you can substitute capital for labor. And if you substituted capital for labor, then maybe you'd end up the point like 10 and 7. And then if you substituted some labor for capital, maybe you could produce with 3 and 15 units of labor. And maybe you could also get up here to And so what you'd want to do is talk to your production managers and think about all the different combinations of capital and labor that would allow you to produce 20 units of output. And once you have that, and then you can just go ahead and graph it. And so therefore, let's see, I got some numbers here. So I'll try to graph it relatively accurately here. And let's see. So we have 5 and 10. And we got 15 and 5. We'll graph that there. And 3 units of labor and 15 capital. And 10 units of labor and 7 capital. We have something like this. And let's see. Again, if you have the actual specific numbers, we go ahead and graph it like this. We have these points, and you could imagine continuing going on like this to get as many as you possibly want. And when you do that, then you just connect the dots. You connect that here. And by drawing a nice smooth curve, what we're really assuming is that you could actually use any of the combinations in between here. So graphically, we have a way to pick all the different combinations of capital and labor that will produce 20 units of output. So if that was how much output the firm wanted to produce every say month, then these would be their different options. And this just shows the technical possibilities. And again, you should also probably note that this is the technical possibilities when you're actually using these inputs efficiently. Another thing you can do is, obviously, if you've ever done a home improvement job, try to make a table or something like that. You can make bad cuts. You could get a wood and you start cutting it up, and you make bad cuts, and you end up with a lot of scrap wood at the end of it. So if you did that, then you would probably need to be using more wood than you would have to. So if you make mistakes, you could waste resources. we're assuming these resources aren't wasted. They're simply different options that you'd have to produce 20 units of a good. And now we picked that 20 very arbitrarily. So in addition to one isoquant, we'd actually have a whole family of isoquants. And the shape of these different isoquants, the location of these different isoquants would show, say, for instance, if you wanted to produce 30 or 50, you'd have a whole family of isoquants. The family of isoquants would in effect be describing a production function like this. So it's a way to graphically show this. Again, if you think of a level curves or contour lines, contour lines on a map, we're showing different heights of production, if you want to think of it analogous to elevation on a map. So this is where you'd be producing 50 units of output. And obviously, if you go farther to the northeast, you'd be able to produce more output because you're using more inputs. But then, as a matter of we live in a world of scarcity, if you're here at the origin, 0, 0, your output's got to be 0 because you're assuming that this is a good that has to be produced. You have to have at least some resources. Now, the exact shape of these indifference curve, see, there's a parallel to utility theory here, so I messed up there. The exact shape of these isoquants are going to show the nature of production, how easy it is to substitute capital for labor in producing the good. And just as what we saw with utility functions, and they have this in the book because it ends up paralleling it. You can have, it could be that you have a production function where you have the inputs are perfect substitutes, in which case the isoquants would be lines. You could also have a case where they'd be perfect complements. That for instance, you have to use 1 unit of labor and 1 unit of capital to produce 1 unit of output. If that's the case, then you have isoquants that would be right angles, just as what we saw with indifference curves for the utility function. So mathematically, it's really paralleling what we had with consumer theory. The production function is analogous to the utility function. There is one difference that's worth noting, and that is like for production function, the number that you get out of it is actually something tangible. If this company is producing mousetraps, you can actually count the number of mousetraps that they produce. Whereas with utility, we were thinking about consumers getting a level of utility or happiness or satisfaction, where we said that we had no intrinsic unit of happiness or utility. So you do have the number that you're getting out of this is a quantity of the good, and it then therefore would allow you to possibly actually estimate empirically. You could actually use data from production and try to estimate a production function for a good. So that's an important thing to note. And one other thing I want to mention is that we focus here on quantities. Quality is also an issue. So quality can be an issue, especially in the real world. We're abstracting from that. So if you think about it, pairs of shoes vary widely in how much they cost. So, that you can have much nicer pairs of shoes that cost a lot more money than the kinds of shoes that I would tend to buy. So there can be differences in quality. We abstract from that. Now, quality would be a little harder to measure. Quality is going to be more like utility in that, if you think about it if you think about like one of your favorite movies or TV shows, and if you had to try to describe, be really precise to say like, why is that your favorite show as opposed to some other show that's similar, but you just don't find quite as enjoyable, you might have a very hard time to actually spell out or specify exactly why it is you think that one is of better quality than the other. All right, same thing with with shoes. The differences in quality of shoes. If you're trying to say like, how could you actually measure or how could you say that this pair of shoes is of higher quality than the other, or how did you say that they're more comfortable? You might know that they're more comfortable if you wear them, but I mean, how do you actually sort of measure that? Well, so quality gets into something that's a little bit more like utility, in that it's hard to measure. And that's why, in this case, we simply focus on the one thing we know we can measure and count, and that's quantities. And when you're holding, in effect, sort of holding quality constant or abstracting from quality, you can actually estimate a production function. And so, in the area of industrial engineering or operations research, or sometimes economists working for a business, or economists in their research might be trying to estimate production functions. And that's something you can actually do that you couldn't do for utility functions. You can actually estimate somebody's utility function, because the units of utility aren't something you can count or measure. Okay, so that's how we get isoquants.